Can you explain how shore power works and why it's so important for environmental sustainability?
Okay, so the EPA Environmental Protection Agency had been providing grants to different ports throughout the US in order for them to control what they call the greenhouse emission gases. Typically, when you go to a port and there are so many ships that are basically they stop and their anchor at the port. While they are there, they're like a small cities, right? So while they're there,
Shore power has the potential to revolutionize the cruise industry by significantly reducing its environmental impact. But what exactly is shore power, and why is it so important for both the cruise industry and environmental sustainability? Join us as we discuss the real-world applications, the engineering challenges of adopting this technology, and the positive impact it has on coastal communities and marine life. Grace Patino, Senior Vice President and Electrical Engineer at WSP, will take us through the concept of shore power and its critical role in minimizing the environmental footprint of cruise ships. I'm your host, Matt Picardal, and this is the Structural Engineering Channel. Grace, thanks so much for joining us. Can you share a bit about yourself and how you got started in electrical engineering, particularly in the field of movable bridges?
well, thank you, Matt. It's actually a pleasure to join you. I started my career, I was actually born and raised in Venezuela, started my career back in my country, and then migrated to the United States and continued my career shortly after I came to the US. And been doing this, the first part of my career was actually in utility. So I used to work for Lakeland Electric, a utility company. Later on, I went to work for WSP, and I actually had been with WSP for almost 25 years now. Started from those 25 years, from the beginning, started in movable bridges basically as an entry-level engineer. Slowly but surely, I managed to go higher up in my career, and now I'm actually the manager for the electrical movable bridge team for WSP. Part of the conversations that I know we're going to get into is I had got a call from one of our offices asking if we could actually take care of Port Miami and the shore power project, and I thought it was interesting. And aside from being interesting, it's actually a project that goes back to my roots, which was in the utility business.
Oh, okay. Yeah, and I know you mentioned movable bridges. For our audience that may not be familiar with movable bridges, I'm thinking those are the drawbridges, maybe the transportation bridges. Could you explain more about movable bridges?
Sure. So movable bridges in general, you're correct. Most people know them by drawbridges. There are different types of movable bridges. There are swim bridges that are actually the ones that rotate. The vascular bridges, which is most of the drawbridges that people call drawbridges, which are the ones that had leaves and they just open and close. There is also vertical lift bridges that basically open up the whole channel for the navigational channel for the ships to go through. So in general, all movable bridges go over water. They are used for transportation, but they're also used for our railroad industry.
And what are the challenges with regards to that? Maybe the electrical and control systems. I imagine that's got to be pretty complicated with some of the challenges that you encounter.
Correct. Challenges is a movable bridge engineer in general has to be able to coordinate all the different disciplines because we have to work with mechanical team for the machinery that goes into the movable bridges, but we also have to coordinate with the structural engineers to make sure that everything is balanced and that when we open a bridge is nothing is heating another element within the bridge. Like everything is clear. So we always have to think about the rotation of or the movement of the bridge and make sure that the elements are clear. Like you said, control systems for movable bridges, but in my mind, the most important thing when designing movable bridges is actually the safety of the vehicular traffic, the marine traffic, and the pedestrian traffic that actually commute through those bridges.
Yeah, interesting. And for, yeah, I imagine, because my specialty is structural, so I imagine if something's moving, we have to make sure that it's not just a static. Now it's all the electrical conduits, all the systems. If a bridge is moving structurally, we got to make sure those are safe too. And I can imagine the coordination on that one, where now you have a moving structure and we have to make sure everything is coordinated and that all the conduits and electrical systems aren't being damaged or interrupted, even with mechanical, electrical, and plumbing. Yeah.
Yes, yes. And it is important, like I said, to make sure that when you keep that movement in your mind, when you're designing, to make sure that you're not, during that movement, you're not hitting conduits or machinery or stairs or ladders that may be on the way, or cabinets for that matter, because we do have a lot of different electrical elements throughout the bridges, but also mechanical elements.
Did you work on rehabilitation projects for movable bridges? And does that differ from the design of new ones?
Yes, yes. So you just said a new ones is fairly simple. And I say fairly in quotes because, again, it requires coordination between all the disciplines. It's a little bit easier, but people has to be very aware of the requirements in terms of physical space, not only for the equipment to be located at, but also to meet the National Electric Code working clearances that are required for the owner of that structure to maintain the bridges. When we moved into a rehabilitation of movable bridges, which is often what happens with a lot of our bridges, it's hard to see a new movable bridge being built, although they have been some. Most of them are because the existing structure is structurally deficient, not because the electrical or the mechanical systems have issues, because we usually rehabilitate those that have issues. And so it's a little bit more complicated because our spaces are fixed and we have to be mindful of I have so much space to put this. And not only that, but you have to bring new technology to all these bridges that are being rehabilitated. A lot of those use programmable logic controllers, also known as PLCs. So some people wants to stick with the old relay base, which is basically it's more complicated wiring. PLC is basically a computer that tells the bridge open, close, do the gates or the span locks, or different elements within the bridges.
And I know you've also, you mentioned this earlier, that emerging shore power initiatives for the cruise line industry. Can you explain how shore power works and why it's so important for environmental sustainability?
Okay, so the EPA, Environmental Protection Agency, had been providing grants to different ports throughout the US in order for them to control what they call the greenhouse emission gases. Okay. So typically when you go to a port and in this case, I'm going to be referring more to Port Miami because that's the port that we worked on. There are so many ships that are basically they stop and their anchor at the port. While they are there, they're like a small cities, right? So while they're there, they have to keep their refrigerators going. They have to keep all their food, the air conditioning, everything going. And the way they do it is utilizing their own engines, right? Generators that they have within their ships that are usually also on while they're in waters. So all this is constantly emitting gases to the environment. So the Environmental Protection Agency said, well, let's control that and try to maintain our ports clean. And that's when they decided, okay, let's provide grants to those ports that are willing to invest on this. But you talk about shore power, there's two different sides of the shore power, right? A very quick definition of shore power is basically just like in my house, I use the electrical utility to provide me power. On the shore power, the electrical utility is providing power to the ships. That's basically what a shore power is. Now, it sounds simple, but if it was a fixed structure that is always at the port, no issues. It's just like a house. But this structure is moving constantly, right? It's coming and going. And not only that, but it's not one structure. There are different ships that the port has to feed, right? So that's where the challenges come because it's moving equipment basically as a movable bridge. It's moving equipment that is going away and is coming back. So that's what shore power is.
And that initiative is getting more of those facilities or that shore power in place so it can power some of these different, like you were saying, different types of equipment or ships. Is that essentially what that shore power is to get more of that? So that like those big cruise liners don't have to just sit there and generate all of the waste from their generators when they're just sitting there. They can just
Right.
use the shore power.
Correct. That's what it is. But it's also financially beneficial to the ships because now they have a way to get fixed power at a lower cost to them, right? It's an investment, but the return is extremely good for the overall industry.
Yeah. Yeah, I never really thought of it that way. I mean, yeah, that's a lot of wasted energy for those. I've seen those, yeah, those big cruise liners or those big massive ships that come in, and if they're just sitting there and using their own power, it does seem like a waste where you could just charge it up, like you plug it in, similar to what you were saying with your house appliances. Just leave it in there; it'll be cleaner.
Correct.
And how does your experiences with movable bridges factor into this new shore power project?
It's similar. There are many elements that they have to be coordinated closely. There are pieces of equipment that need to be, in the case of Port Miami, they're underground. So if the equipment will not interfere with the daily operations of the port, because they actually have to supply it or restock every ship that comes by. And all those activities is unbelievable how much they have to carry across what we call the apron, which is basically, in a simple term, is the street that is in front of the ship every time the ship is there. So you have a lot of equipment being moved around to carry boxes, pallets with supplies to the ships. So as it's a very interesting. So for the similarities, I had my background in movables. I try to be a very good coordinator among disciplines. I enjoy doing that. But also the fact that we have some of the equipment have to move around the port and being mindful of, again, conflicts that could exist just like in movables. And because of my background on the electrical industry, when I started my career, I actually worked for 5 years for them. And it helped me understand the transmission distribution side, the generation side, and it helped me be able to discuss with the utility items that needed to be discussed in order to implement the project.
Yeah, I imagine it's in terms of all the disciplines, and you're mentioning that it seems like the dock's going to be completely operational while all of this is going around. So it's working around even their schedules and trying not to interfere with the traffic and the moving equipment that's going on there. Seems like a good logistical problem to solve, even with regards to engineering as well.
Yep.
And how long is this shore project? Like how big is it? How long is it going to take to get all of these shore power in place?
So at the moment, and there's, like I said, there's a lot of different equipment and elements that have to be put together. So in simple terms, we have to somewhat install a small substation at every single one of these terminals. That substation is going to take the power from the utility and is going to transform that power down to an available or a usable power to the ship. So we receive 13 kV from the utility, but the ship is can only use 6.6 or 11 kV, right? So we have to use kind of a transformer, but also when you talk about power, you have to be mindful of the power factor. You have to be mindful of the frequencies that that are being used for the two systems. So in order for the utility to say we're signing on the fact that you're going to take our power, we want you to give us back a very good power factor. So that is a portion of the equipment that we have to put in place to transform the power down to a usable level, but also guarantee the utility with a good power factor. So that's one piece of equipment. Then you have the cables that are going to be taken close to the ships. But remember, because the ships are moving and the door, what we call the shore power door at every ship actually varies in location. Okay. We have to take these cables to a fixed location, and then what we use was a cable management system. It's like a little crane that you connect one side of the cables and the other side of the cables are connected to the ship. So that's all. It's like I said, it's a lot of coordination.
Yeah.
You have to be mindful of everything. You have to be mindful that you're like on the rehabilitated movable bridges, you have an existing infrastructure you have to use. So you have to be mindful of the structural loads that you're going to put on these aprons to make sure that they're not exceeded and that they're not compromised for future usage.
And so, yeah, for the moving loads or for the moving cruise ships and whatnot, you're taking essentially the power cable and moving it with the crane to accommodate for those shifting
to a
cruise
door.
ships.
So I don't know if you had ever been in a cruise, but there are different doors that are used for people to come in and out of the ship, for the baggage to come in out of the ship, for the supplies to come in out of the ship. It's the same concept for the shore power. There is a door where the electrical equipment is inside the ship that is the one that is going to be able to take the connectors that we're bringing in.
I see. Yeah, and for in terms of engineering perspective, what are the key challenges that the industry faces when trying to implement more of these shore power systems in their ports?
In my mind is the availability of the equipment made in the US. And like I said, you're dealing with physical spaces that are already there. Some of them are very tight. So some of the equipment that we use is not as small in size, right? So that physical constraint was a challenging portion of it to make sure that we can bring in the equipment and that it will fit in the physical space that the port has available.
Yeah, and for engineers that are looking to get involved in these large scale sustainable projects, what skills or experience or advice do you have for them for being successful in that field?
Just a lot of research, a lot of learning experience, learning curve, I have to say. We all have our concepts. You have your concepts on a structural engineer. I have my electrical engineer concepts. I have worked in transportation projects that are a mix of all the different disciplines. So open-minded to coordination. Don't be thinking on a box that you're only going to be designing the trench where the cable is going to be. Be open-minded that trench may get water, that you want to make sure that everything is operational, that you're actually listening to the client, but also listening to the industry and the suppliers of the equipment because they have done it. There's a lot of shore power outside of the US that had been implemented, especially in Europe, and they can teach you a lot. Obviously, they don't want to give you all the secrets, but then that's when you have to kind of be open-minded and said, okay, what if I do this? How will that affect me or the project basically? So open-minded and be able to coordinate multidisciplines.
Yeah, that's great advice. I know from talking to senior engineers, it's always a matter of yeah, of course, the experience, but they are open-minded. They're the ones that talk to the contractors. Those are the ones that talk to different disciplines. And I see that similar to yours. A lot of the success comes from bringing all of those perspectives for the good of the project. It's not just it has to be this way because I'm an electrical engineer and it needs to be this way. It's looking at the other disciplines and how it affects everybody. So I appreciate that.
Yep.
And did you have any final piece of advice for students that are just getting into looking to get into these electrical projects coming from school and whatnot?
It is, it's funny that you asked me that question because that's kind of one of the main issues that I see, and not in this project in particular, but overall in our engineering industry. It's like communications was a big thing that everybody went to. So everybody wanted to be a communication engineer. Everybody wanted to be computer engineer. I feel that the U.S. is really lacking electrical engineers, mechanical engineers, even civil and structural engineers.
Yep.
It's very difficult to find them. The number one thing that I tell all the people that I interview, I said, what do you want to be tomorrow? What do you want to be in 3 years, 4 years, 5 years? And it I guess there is a myth out there that tell them that, you know, they can just be project managers. That's the best job they can do in engineering. My advice to all those that are in school is learn to climb step by step. Don't miss any steps because that's where you're going to become a good communicator and coordinator for among disciplines in the future.
I see. So in terms of from when you're interviewing people, it seems sometimes there's that rush to get into project management. Oh, I want to be project manager. I want to be project manager. How do I get there? But it seems like you're saying that don't skip the steps. There's that technical aspect too, where you do have to learn what the technical side of it is, and then as you'll eventually become a project manager, and the technical with the management skills looks like that'll make you a good project manager.
Yes.
Awesome. Thanks so much,
Little
Grace.
by little.
Yes, little by little. You can't rush it.
No. I have a quick story. I lost my job with another company in between the utility and WSP. And when I started looking for a job, I was a operations manager at the previous position, and it was for a very short time. And I went to look for that position, a management position with another company. And the person that interviewed me said, you have great potential, but if I don't want to give you this job because I think you have a lot to learn, climb the ladder and move on.
And do you
So
think he was right?
I think he was absolutely right. And WSP is very good at helping the engineers to actually climb that ladder and mentor the engineers to be able to become managers or project managers, or in the future to grow with WSP.
Yeah, with that in mind, I'm just curious, like, how does that ladder look like in terms of, let's say for electrical engineering? Is it learning about one aspect of electrical engineering, then the next aspect, then maybe coordination, or how does that ladder look like from a overall view?
It is learning little by little, right? Obviously, it's critical that you have a good manager that is listening and is taking you a step by step and advises you when you have to be working more on one part of your career or another. So that's critical. WSP has different levels of engineering, but we also have kind of two different paths within WSP, which is a technical. There's a lot of engineers. Like some people say we're nerds and we kind of want to be in the books and we don't want to. We prefer to be not bothered by anything, right? Those are the more technical people that enjoy the technical side of it. So often when we start on the technical portion, and then little by little, we start migrating to the management or supervisory positions if we do want to do that. But if we want to stay within that technical side, WSP is a great company because we promote that technical knowledge and the technical excellence that our employees have.
That's really cool. Yeah, it's having a choice between technical or management because people are different. People have different interests, so that's pretty cool that they provide those two paths.
Yeah.
But Grace, I just wanted to thank you for having this conversation with me. I really appreciate it, and I learned a lot. That was pretty cool to learn about those initiatives and about those projects, and even just a little more about electrical engineering. So it's great for me as a structural engineer to talk more about other disciplines. So I appreciate that.
Same here. Thank you for giving me the opportunity to join and to be able to talk about a little bit of everything.
Yeah,
Sometimes I and it is the nature of engineers in general is we have to know a little bit of everything to be able to coordinate among disciplines.
absolutely. I hope you enjoyed the episode today. We'd love to hear your feedback, comments, and or questions. To leave them, please visit structuralengineeringchannel.com. There you'll find a summary of the key points discussed in today's episode, as well as links to any of the resources or websites mentioned during this episode. Don't forget to subscribe to Apple Podcasts, Spotify, or wherever you listen to your podcast. Until next time, we wish you the best in all of your structural engineering endeavors.